Look up. The night sky is a tapestry of distant suns. There are billions of stars in our galaxy alone. And our galaxy is just one of billions. Each star could be a sun to a family of planets. The sheer number of worlds is almost impossible to grasp. It is a number so large it humbles the mind. Faced with this cosmic grandeur, we are compelled to ask a simple, profound question. A question humanity has whispered for centuries, first around campfires, and now through radio telescopes. Are we alone? This question resonates deep within us, a blend of hope and fear, of curiosity and awe. To understand the search, we must first understand the scale. Imagine our sun is the size of a single grain of sand. At this scale, the nearest star, Proxima Centauri, would be another grain of sand over 4 miles away. Now, imagine holding a handful of sand. That handful represents the thousands of stars you can see with your naked eye. But the entire Milky Way galaxy, our home, would be a beach stretching for hundreds of miles, containing hundreds of billions of grains of sand. Each grain a sun, each potentially with its own system of planets. And that is just our own galaxy. Beyond the Milky Way lies a cosmic ocean filled with other island universes. Through our most powerful telescopes, we can see that for every star in our galaxy, there is likely another entire galaxy out there in the void. Billions of them. Each one a swirling city of stars, gas, and dust. Each one a potential cradle for life. The light from these distant galaxies has traveled for billions of years to reach us. We are, in effect, looking back in time. So, how do we search for something we have never seen? Scientists have developed clever methods to scan the heavens for clues. One of the most successful is the search for exoplanets, planets orbiting other stars. For a long time, these were purely theoretical. Now, we know of thousands. One primary technique is the transit method. We point a telescope, like the Kepler or TESS space telescopes, at a patch of sky and watch the stars. If a planet passes in front of its star from our point of view, it will block a tiny fraction of the starlight, causing a slight, periodic dimming. It is like watching for the shadow of a gnat flying in front of a distant searchlight. Once we find a planet, the investigation truly begins. We can learn its size from how much light it blocks. We can learn its orbital period from how often the dimming repeats. From this, we can calculate its distance from its star. This allows us to determine if the planet lies within the habitable zone. This is not a guarantee of life, but simply the region where temperatures could be just right for liquid water to exist on the surface. Water, as we know it, is essential for life. So, finding a rocky Earth-sized planet in the habitable zone of its star is a top priority. It is like finding a promising spot on a treasure map. But finding a potentially wet world is just the first step. The next, even more exciting step, is to study its atmosphere. As starlight passes through a planet's atmosphere, certain wavelengths of light are absorbed by the gases present. By analyzing the spectrum of light, we can look for biosignatures, gases that might indicate the presence of life. Beyond the methodical search of science, there is the realm of personal experience. For decades, people have reported strange things in the sky. Objects that move in ways that defy conventional aircraft. Lights that perform impossible maneuvers. These are often called UFOs, or more recently, UAPs, unidentified anomalous phenomena. Reports come from ordinary citizens, trained observers, commercial pilots, military pilots. The sheer volume of accounts is a phenomenon in itself. It is crucial to approach these stories with a scientific mindset. An unidentified object is just that. Unidentified. It does not automatically mean extraterrestrial. The history of investigations is filled with cases later explained by mundane phenomena. Weather balloons, atmospheric effects, secret military aircraft, misidentification of planets like Venus. The human brain is an excellent pattern recognition machine, but it can be easily fooled. especially when observing something unfamiliar at a distance. Eyewitness testimony, while compelling, is notoriously unreliable. We must remain skeptical, but open. A small fraction remains stubbornly unexplained, even after rigorous investigation by government and scientific bodies. Videos released by the U.S. Navy, for example, show objects tracked by advanced sensor systems that appear to accelerate and change direction in ways no known technology can replicate. These are not blurry backyard photos. They are data from some of the most sophisticated military hardware on the planet. And the pilots who witness them are credible, trained professionals. So, what are we to make of this? We must be careful not to leap to conclusions. Absence of a conventional explanation is not proof of an unconventional one. It simply means we do not have enough data. Perhaps natural phenomena we do not yet understand. Perhaps sensor glitches, or advanced drone technology from another nation. Or perhaps something else entirely. Science cannot, and should not, ignore high-quality data, regardless of how strange it seems. The mystery of UAPs invites us to look closer, gather more information, and to ask better questions without prejudice for the answer. The universe appears to be full of potential homes for life, yet we have found no definitive proof of it. This puzzling situation is known as the Fermi paradox, who famously asked, "Where is everybody?" If life is common and some of it develops intelligence and technology, the galaxy should be teeming with civilizations. Some would be millions or billions of years older than us. Their technology would be like magic. They'd have time to colonize the galaxy or leave unmistakable signs. Yet we see nothing. Scientists propose many possible solutions. One category is sobering. Perhaps life is incredibly rare. The right kind of star, a stable planet in the right orbit, the presence of heavy elements, a large moon for stability, the jump from non-living chemistry to biology. This is the rare Earth hypothesis. Another possibility: simple life is common but complex. Intelligent life is the bottleneck. It took 4 billion years for intelligence on Earth. Our planet faced extinction-level events like an asteroid impact, a nearby supernova, a gamma-ray burst. Any could sterilize a world and reset the clock. Perhaps most worlds aren't stable long enough. Civilizations might arise and then be snuffed out. This is humbling. A more optimistic set of solutions says they're out there, but we can't see or hear them. Maybe their tech looks like nature to us. Maybe they use communication we can't detect. Modulated neutrinos, gravitational waves. Maybe they simply have no interest. Or maybe there's a galactic prime directive. Let young civilizations develop on their own. Possibilities range from mundane to truly mind-bending. Imagine waking up tomorrow to the news. A confirmed signal, an undeniable biosignature from a distant world. The discovery of a single microbe on Mars. Evidence of a vast ecosystem under the ice of Europa. How would humanity react? The discovery of life beyond Earth, even simple microbial life, would be one of the most profound moments in human history. It would fundamentally reframe our place in the universe. Science would be energized with a new, unifying purpose. We would devote immense resources to studying this new life, its chemistry, its genetics, its origin. Is its DNA like ours? Does it even have DNA? These questions would launch a new era of biology, religion. Philosophy would grapple with the implications. What does it mean for our creation stories? What is our moral obligation to this other life? We are the first generation with the tools for a serious scientific search. We have built telescopes that can see exoplanet atmospheres. We have sent robotic emissaries across our solar system. We listen for whispers from the stars. The search is underway. The path forward is clear. We must keep looking. This quest is not just about finding aliens. It is also about finding ourselves. So the next time you look up at the night sky, remember, You are not just seeing stars. You are seeing possibilities, potential suns, potential worlds, potential life. We do not know if we are alone. The universe has not yet told us its secret, but the journey ennobles us and reminds us to keep looking up. The answer is out there.